In this video, we are going to look at complement addition. So far we have looked at writing positive binary numbers, but we need to have a way of writing negative numbers as well. And so in order to work with negative numbers, we need to use something called 2's complement form. So in order to get a negative number into 2's complement form, you're going to write the number in binary. Then you're going to invert all of the numbers and add 1. So for example, we're going to write numbers using 1 byte and 2's complement form for negative. So again, 1 byte is using 8 digits and then 2's complement form. So the first thing we're going to do is going to write the number in binary. So in this example, we have 120. It's a positive number, so we're going to store it using its usual binary form. So we're using 1 byte, so it needs to be 8 bits. And what I like to do is I'm going to write out a table here with 8 spots, and I'm writing in the powers of 2 since we're in binary, starting with 2 to the power of 0, and then up with 2 to the power of 7. So there's my 8 spots that I want to fill. And because we're specifically using 1 byte, you want a number in all of the spots. Even if it's a 0 in the start, there's not unnecessary numbers when it comes to the numbers in this chart. We need to fill them all out. And so I want to see how high in this chart can I go before I go over 120. And in this case, 64, or 2 to the power of 6, is the highest I can go. So I'm going to put a 0 in the first one. If I put a 1 here, I'm already at 128, which is too high for 120. I'm already over. So I'm going to put a 0 here. Now in 2's complement form, if it's a positive number, it will have a 0 in this spot. So there's a good kind of hint for you to know you're on the right track. So I'm going to put a 1 in this place. So if I put a 1 here, how many numbers do I have left to go? So I've used up 64, and if I subtract that from 120, I have 56 numbers left. So I'm going to repeat that process with now 56. What's the highest power I can use to get to 56? And that's going to be 2 to the power of 5. So I'm going to put a 1 there, and then I'm going to see how much do I have left. So I'm taking 56, taking away 32, I have 24 left. So the highest power I can use is 2 to the power of 4, or 16, which gives me 8 numbers left. So I'm going to put a 1 in the 8th place, and then I have nothing left, so I can fill up the rest with zeros. So again, just to double check, if I do 8 plus 16 plus 32 plus 64, I get to 120. Because the question says we need to store it in 1 byte, we do have to use all of the spaces again. We do not take away any zeros. So therefore 120 is 0, 1, 1, 1, 1, 0, 0, 0. So now if I want to represent negative 103, this is a negative number, so we're going to use 2's complement form. Our first step is going to write it in regular binary form, and we're using 1 byte, so we're going to write it out using 8 bits. So again, I'm going to add my chart to the bottom here, and I'm going to write 103, the positive number, in binary, and then we will invert it and add 1 in order to get to the negative number. So I'm just thinking of 103 positive. The highest I can go again is this column here is 64. I'm going to put a 0 here, put a 1, and if I use 64 numbers, then I have 39 left. So I'm going to put a 1 in the 32's place, and that leaves me with 7 left. So I can't go here. I can't go here. That's too high. I'm going to put a 1 in the 4's place, which leaves me with 3 left. So I put a 1 in the 2's place, which leaves me with 1 left. And there, and again, I'm going to check by doing 1 plus 2 plus 4 plus 32 plus 64 should get me back to 103. So 103 is 0, 1, 1, 0, 0, 1, 1, 1. Now, if I want to write that as a negative, I'm going to put it into 2's complement form. So to do that, I'm going to invert these numbers, which means I'm going to switch all the zeros to ones and all the ones to zeros. Okay, so I'm just changing each of the numbers to the opposite. And then I want to add 1, which in binary, it's nice and easy if we have a 0 here. I'm just going to put that 0 and make it a 1. So I'm going to the next binary number down, and I'm adding 1. So therefore, 103 is 0, 1, 1, 0, 0, 1, 1, 1. But negative 103 is going to be the inverted and add 1. So 1, 0, 0, 1, 1, 0, 0, 1. Again, a good check is that if it's a negative number, it will have a 1 here. If it's a positive number, it will have a 0 there. Okay, I want you to try this one. You're going to write 95, the positive number, in binary, and then invert it and add 1 to get to the negative number, and then start up the video again when you're ready. Okay, so if we want to write it as a negative, I first have to write it as a positive number. And so the highest I can go here is the 64. And if I do that, then that means I'm going to have 31 left over. So I can't use the 32, but I can use the 16, which gives me 15 left over. And then I can use the 8, the 4, the 2, and the 1. And again, if we can double check by adding these up. So 1 plus 2 plus 4 plus 8 plus 16 plus 64 gets me to 95. Then I'm going to invert. I'm changing all the zeros to ones and all the ones to zeros. And then I'm going to add 1, which in this case, because this is a 0, I can just make it a 1. And I've now added 1. So negative 95 is going to be 1, 0, 1, 0, 0, 0, 0, 1. Okay, so I want you to try these 3. Again, you're using 8 bits and 2's complement form for negatives. And then start up the video again when you're ready. Okay, so 45, if we write 45 in binary, we get this. And because it's already positive, I don't need to invert and add 1. I can just leave it at that. And we can check by doing 1 plus 4 plus 8 plus 32, and we get 45. For our negative number, we're first going to write 24 as a binary number, and then we're going to invert and add 1. And we get 1, 1, 1, 0, 1, 0, 0, 0. And we can check these ones by using the 128's place as a negative 128. So we get negative 128 plus 64 plus 32 plus 8 in order to get to negative 24. And for negative 113, again, we're going to write 113 in binary. Then we're going to invert and add 1. And we can check by using this as a negative 128's place. So we do negative 128 plus 8 plus 4 plus 2 plus 1, and we get to negative 113. So now that we know how to write negative numbers in 2's complement form, that means we can now perform calculations using both positive and negative numbers. So for example, 72 plus a negative 12, we can now do in binary using 2's complement form and complement addition. So what we're going to do is first write each of those numbers in binary or 2's complement form. So 72 I'm writing in regular binary. Negative 12 I'm putting into 2's complement form. And now I can perform my normal addition using those two numbers. So addition, just like we did before, I'm going to start at this side and I get 0, 0, 1, 1, 1, 1, 0, 1. So I'm going to put a 0, carry a 1, 0, 1. And when we do this addition, you'll notice we get a 9th bit. But because we're only using 1 byte, we're going to drop the 9th bit and get an answer of 00111100. And we can always check by converting back to a decimal. And so we know our answer is positive, and we're going to do 32 plus 16 plus 8 plus 4, and we get back to 60, which is the correct answer of 72 plus negative 12. So we can always check by converting back to a decimal number as well. So now that we know how to work with negative numbers, we can write each number using binary or 2's complement form, and then do regular binary addition. If you end up with a 9th bit, we drop that 9th bit because we're only working in 8 bits. We're only working with 1 byte. So I'm not going to worry about the 9th bit, I'm going to drop that. And if I convert my remaining back, I do get to the right answer. So I want you to try this one. Pause the video and start it up again when you're ready. Okay, so I'm first going to write them in binary or 2's complement form. So 102 I write in binary. Negative 94 I'm writing in 2's complement form. And then I'm going to do my regular addition. So in this case, I get 0 and then 1 0. Put the 0, carry the 1. 1 0, put the 0, carry the 1. 1 0 1 0. Put the 0, carry the 1, 1 0, put the 0, carry the 1, and then 1 0, and again we're going to drop that 9th bit, so we get an answer of 0 0 0 0 1 0 0 0, and if we convert that back into a decimal, we get 8, which is the correct answer of 102 plus a negative 94. So I want you to try these 3, pause the video, and then start it up again when you're ready. Okay, so in our first one, you should end up with an answer of 001 00011, which is 35 if we convert it back to a decimal. In the next one, we get 00101 which is 46 if we convert it back. And finally, the last one, we get 10010110, which works out to negative 106 if we convert it back to a decimal. Now, if we look at some integer rules, we can also expand this to work with other sorts of additions and subtractions. For example, we can think of this in terms of money. If I have A plus negative B, that's the same as A minus B. So if I add debt, the amount of money I have is going to go down, right? So adding a negative is the same as subtracting. Subtracting a negative is the same as adding. So if I take away debt, then the amount of money you have goes up. Right? And so adding a negative is the same as subtracting. Subtracting a negative is the same as adding. We can also think of this as adding ice cubes to a bowl of soup. So if I add ice cubes, the soup's going to get colder. If I take some ice cubes out, the soup will get warmer, kind of. So if I remove coldness, it gets warmer. If I add coldness, it gets colder. And so if I'm looking at a problem like 72 minus 12, that's the same as doing 72 plus a negative 12, right? And so I can use complement addition to do subtraction problems. So same as I did before, I'm going to write 72 in binary, negative 12 in 2's complement form, and then I'm going to perform the addition. Here we drop the 9th bit. We see our final answer is 00111100. And if we convert it back to a decimal, we get the answer of 60, which is the same thing as 72 minus 12. So I want you to try this one, pause the video, and start it up again when you're ready. Okay, so in this one, I'm going to think of this as 106 plus a negative 48. I'm going to write 106 in binary, negative 48 in 2's complement form, and then perform the addition. I'm going to drop that 9th bit to get an answer of 001111010, which when converted to a decimal gets us to 58. So I want you to try these ones. You're going to perform the addition using complement addition. So don't write them in binary form and subtract them. I want you to do complement addition here using 2's complement form. So the first one, we're going to think of it as 32 plus a negative 52, and we get an answer of 111011100, which converts to negative 20 if we convert it back to a decimal. Number 2, we're going to think of this as 64 plus a negative 45, and we get 0001011, which is 19 as a decimal. And finally, we get negative 12 plus a negative 54, and we get 1011110, or negative 66 if we convert it back to a decimal.